You did some work with the Navy's nuclear program on what's called the Next Generation Air Particle Detector.
Mhm.
And basically, when did you do that work and what did that work involve?
Oh my goodness, it was another lifetime ago almost. When I used to work at the former Nevada test site, I was doing radiological emergency response, and one of the, I guess it was really at the time it was more of a side job. So at the time I was something of an expert in air monitoring, and they asked me to redesign it. So they had an old one, and they wanted it to have less false alarms. They wanted to improve the sensitivity. They wanted to improve the response time, things of that nature, and if they could make it lighter. And so I came up with some ideas and we started the redesign. And we came up with a final design that we were going to go with. But before I got to do any of the field testing for that, I changed employers
Okay.
and went to work at the waste isolation pilot plant, geological repository for transuranic waste in southeast New Mexico.
Now, these detectors, they're used on subs and carriers.
Yes.
And what's the basic purpose?
It's pretty much emergency response again. It comes down to, so if they had a release, if there was a breach in the containment, if you had some kind of an accident, then the more direct route for radiological exposure is aerosol, radioactive aerosol. And so you want to be able to see that before it gets to a level that would be hazardous to a worker. You want to know that it's happening before it becomes a health concern. That way you can take action, right? You can put on respirators, you can look at what the problem is, you can address it, you can shut bulkheads, you can mitigate that and keep everybody safe.
You have experience then, working among Navy nukes, and you have in your work as a professor of nuclear engineering, I think you just have a lot of familiarity with the world that Navy nukes are in. As you think about young people who are interested in getting into that kind of work in the Navy nuke program, what sorts of traits and skills do you think young people who are successful at that kind of work, what sorts of traits and skills do they possess?
Being hardworking, liking math and science.
What kinds of things should they study to prepare for nukes?
Oh, math. So you need to be able to have calculus. You want statistics, and you're going to need science. You're going to need some physics. You're going to need a lot of physics and chemistry.
Do you have a sense of what kinds of things nukes in training are going to learn in the process of their schooling?
They're going to learn thermal hydraulics. They're going to learn reactor physics. They're going to learn a little bit of materials. They're going to learn radiation detection. They're going to learn some really basic concepts in shielding.
Thermohydraulics. So what is that?
Oh, how you do heat transfer from the fuel. So a nuclear reactor, the basic principle is identical to that of say geothermal or coal or natural gas. In all of those, you simply have a heat source that boils water. And that boiled water then expands and turns a turbine, which makes electricity. And then you got to condense that wet steam and then run it back through the reactor, whatever your heat source is, run it back through the heat source. And so how that takes place, that's the thermal hydraulics, how the heat gets moved from the reactor to the coolant to the steam generator to the turbine to the condenser, and you make that whole cycle go. So there's a whole process that we've known for many centuries how to do that, but now we've optimized that in modern power systems.
What is shielding?
Oh, so if you've got a radiation source, how much concrete, how much steel, how much water do you need to get those radiation levels down, say, to background, right? So natural background, it's our design specification. And if you can get, say, a nuclear reactor or spent fuel, you can attenuate that down to background levels. It's entirely innocuous at that point in terms of any kind of regulatory concern.
And then detecting, what does that mean in this context?
So you got to know where it is, right? You can't see it, smell it, touch it, hear it. And so you have to have a detector. So they're going to have to know how to operate a detector, basic detectors. Really, it just comes down to say a GM, a Geiger Mueller. They're going to know how to set it, how to read it, how to calibrate it, how to operate it, how to look for contamination. They're just going to have to know basics of radiation detection. How materials behave. So things that are plastic, things that are amorphous, things that are crystalline. So it's very difficult to get a metal that's not in a crystal form. And that the way that the metal will evolve with impurities and with insults, with thermal cycling, how does that metal evolve? How do the cracks start? How do the defects propagate to weaken the material as opposed to something that might be amorphous? And then it's going to depend on the actual material that's being made, how those things will evolve. So basic material science.
I'm sure in your line of work as a professor of nuclear engineering, and plus you have history working actually with the nuke program, I'm sure you've picked up over the years the reputation of the Navy Nuke School. How would you summarize the reputation, that the assessment you have of the reputation of the school as you've sort of picked things up over the years?
Oh, it's fantastic. As you might recall, the first thing that you asked me was, what kind of qualities are needed? Well, it's hard work and a love of math and physics, and you're not going to get through the Navy Nuke program if you don't have that. So it's kind of like a weed out process for good operators in the nuclear industry. If you made it through Navy Nuke, you're going to do very well in industry.
Yeah, so I'd love to hear you say something about that. So let's say we've got a guy or gal goes into the Navy at 18, finishes a 6-year term, decides just to do the one enlistment. Now that person's 24 years old. What would you say that person's positioned to do after 6 years as a Navy nuke?
Oh, they should just go to industry and get paid really well.
Yeah. What
For
industry meaning? What do you have particularly in your mind?
making electricity. Yeah, making electricity. Same thing they did in the Navy. Well, there they also did propulsion, but same concept.
Yeah. And is it your sense, at least, at the moment we're talking, that there's a high demand for Navy nukes in industry?
Yeah. So I mean, and pretty much they can almost pick any job they want in operations, right? If they wanted to be a crane operator, a fork truck operator, if they wanted to operate manipulators, if they wanted to do radiation detection via pretty much anything because they've got that background. And they're already speaking the right language. They've already got their math and their basic sciences down. And they've already demonstrated that they can work hard and they can be consistent and reliable. So it's like, it's a perfect fit.
And would you add to that, maybe part of reliable, would you add to that trustworthy? Because, it's understood that to work in that field, you do have to have a high level of security clearance. And presumably, if you make it through, in good standing, then, you've met your responsibilities in terms of keeping things secret. So does part of that reputation include, in addition to the math skills, the hard work skills, also just here's a person that we can trust with information?
Absolutely. It's a little more practical than that, in that in our industry, nuclear safety is at levels that people outside nuclear have no idea just how high it is. It spins the heads of most people when they come in and see what nuclear quality means, what compliance, what our safety standards are. A bolt, the same bolt that you might get for the oil industry, it might cost you $15, but in the nuclear industry, it can easily cost you 100 because you've got to make sure that it was made the right way. You've got to make sure that the people that made it had the right certification. You've got to make sure that that once you've received it, it meets all of the specifications. You've got a whole bunch of people, qualified, usually engineers, quality engineers, that have to review the documentation on its entire history since it was forged. Just to make sure that everything that you take credit for, if it's safety significant, everything you take credit for is there. Whereas in other industries, it's just a bolt, even though it's the same bolt. And so what we have in the nuclear industry is something called disciplined conduct of operations. And probably and when I say it's more, the more practical realization is that we expect verbatim compliance. That's something that you really don't get in popular culture, verbatim compliance. Meaning that if you can't do exactly what a procedure says, word for word, verbatim, you stop work, everybody stops work, you put everything in a safe situation, and you figure out why the procedure was wrong, why you couldn't do the procedure. Because anything you're doing in a nuclear power plant or any category 2 nuclear facility has to receive in-depth layers of review from multiple experts. And if you can't do verbatim compliance on a procedure, that means that that process failed. And that can cost potentially millions of dollars a day. And so to make sure that that never happens, you've got extreme reviews on these procedures to make sure that an operator can do verbatim compliance, because we know that if they do verbatim compliance, we get exactly what we expected. Our quality is high. In the nuclear industry, your biggest products, in a sense, are quality, safety, and regulatory compliance. And then after you've done that, then you can start to make product. It's a very different paradigm. And so having people that came from the military, they're much more conditioned to be able to do verbatim compliance, so that you would never want a person on your salary that would take a shortcut. They would say, oh, I can finish this procedure if I do it my way. Or I don't need to do this work package the way that the work package says. I think I know a better way. When you find somebody like that in our industry, you get rid of them. You go find a desk for them to go and issue bus passes to workers.
Mm. So when I'm hearing verbatim compliance, the phrase that goes through my mind is actually a phrase I heard probably hundreds of times in boot camp, and that is attention to detail. And it sounds to me like, I mean, then one of the key traits of a person who's going to succeed in this field is just, a personality that is open to paying attention to detail and, following specific rules that are, specific guidelines in the precise way that they should be followed. I think this is my last question, and it'll maybe sound maybe really simplistic. But when you think about the Navy's nuclear program, why is it important?
Well, if you don't have a strong military, then people will take what you have. If you don't have a strong police force, people will, it might makes right at that point. If you don't have a way to enforce your rules are meaningless.
Yeah,
And the Navy, largely what made us one of the most prosperous nations on the planet, because it allows us to guarantee that people follow the rules of international trade. And because we can trade, we can enjoy this amazing standard of living, because we have all of these things that are imported and that are exported, so that we can optimize our buying power. So Navy's pretty important.
yeah,
So is the Air Force, but it all just allows us to enjoy the rule of law.
yeah. And one of the key assets the Navy has, of course, is the aircraft carrier, and the aircraft carriers don't go without the nuclear reactors. So you've got to have the nukes there on the job. Is there anything else you'd like to add?
Well, probably the most profound thing is that when it comes to an energy source for electricity, because of the energy density, it just becomes the most environmentally friendly energy source you can have, despite common anti-nuclear rhetoric to the contrary. And the reason why is energy density. That's why a lot of people like fusion. It's an incredibly high energy density. Now, there isn't any energy source that doesn't have waste, but with nuclear, it's just so overwhelmingly sustainable and environmentally friendly and crazy safe. If you include Chernobyl with the statistics for nuclear energy, it's still safer than wind. If you exclude Chernobyl, you say, well, that's like comparing the Hindenburg to modern air travel. So we don't include the Hindenburg in air statistics. If you did that, then it's safer than solar.
Really?
It's just crazy safe, simply because, I mean, well, as an example, Fukushima didn't kill any members of the public, nor will it ever is it ever expected to, nor is it ever even expected to create a single cancer. There are no expected measurable medical effects because the dose was too low. Radiation is ubiquitous. The human body's had it for since the beginning. Radioactivity's been with us since the beginning. So that if you were to look, and one of the things that terrifies people is nuclear waste. It's like this big boogeyman. Even though nuclear energy has provided 20% of our electricity for about 50 years, right? Largest economy on the planet. 50 years, all that manufacturing, all that electricity, 20% of it was nuclear. And all the spent fuel from all of that energy would not fill up a single football field about 10 meters high.
Wow.
And when we encapsulate it in those packages at the fence, by law, the dose rate of that fence is again right below background. It's about 1/3 of your annual background right at the fence. Just the best energy source that's out there from an environmental perspective, from a safety perspective, from a national security perspective, from a sustainable perspective. Because uranium is ubiquitous, 3 parts per million anywhere you go. It's more abundant than tin. And people are terrified of it.
So it sounds like there are a lot of reasons to, for young people who, have the mathematical scientific interest in these kinds of things, a lot of reasons for them to look at this. It sounds like it's there are a lot of possibilities in this field.
Oh yeah, it's the future.
Excellent.
It's impossible for us to continue to enjoy a high standard of living and to start to share that with everybody without going nuclear. It's the only way.